Operations with plane vectors, and what we mean by plane vectors here is vectors in 2 dimensions. There's not a big deal of difference when you use 3 dimensions. We can add 2 vectors together. Now let's consider a situation. Imagine that the red dot below is you, and you're being tugged by a force in this direction and a force in this direction. Those 2 forces could be replaced by a single force, which is the sum of those 2 forces. They could be replaced by this force, so that we don't need the 2 original forces. You'd get exactly the same effect from being pulled by this force. We can add 2 vectors together diagrammatically. And the way we do this is we take the first of the vectors, let's say vector A, and then we place the vector B that we're adding to it so that the tail of B is on the tip of A. Look at the arrows. The sum is then the third side of that triangle. Note the direction of the arrows. We're going from this corner to this corner, both along A and B individually, and along the vector A plus B directly. This is easy in component form. So let's say that A was the vector 3, -2, and B was 5, 3. A plus B is 8, 1. You just add the components. 3 plus 5 is 8. -2 plus 3 is 1. To subtract one vector from another, we simply add its negative. So to do A minus B, let's start by putting A on the diagram, and then we'll put the negative of B. So the vector B is a vector that goes upwards rather than negative B, which goes downwards. So A minus B will be the third side of the triangle. Note once again the directions of the arrows. If A is 3, -2 and B is 5, 3, then A take away B, we just subtract the components. So it's going to be 3, -2, add -5, -3. So 3 add -5 is -2, -2 add -3 is -5. Vectors can be multiplied by scalars. So here's A. Let's say that A is 3, -2. 2A is a vector in the same direction that's twice as long. So 2A is just 6, -4. So to multiply by a scalar, just multiply each component.